Okay, so let's go back to percent composition. Okay, so first we have percent weight. Percent weight. Okay. Okay, so basically, class, what percent weight means is just the mass of solute all over the mass of solution times 100 kay percent man, di ba? So that means if you're told nga ang kana nga solution is 30% by weight, 30% by weight of like iron, example, 30% weight iron, that means that contains 30 grams of iron in every 100 grams of the solution times 100. Di ba? Okay, that's equal, di ba? 30 divided by 100 is 0.3 times 100, that's 30%. Okay? So, it's also the same as saying that's 30 kilograms of iron for every 100 kilograms of iron. Because that's still 30%. Or, I could even say that's 3 kilogram of iron for every 10 kilogram of solution. Sorry, solution na siya, class. This is solution. Diba? That's the same. So, you can just, the advantage of weight percent, class, is that you can just adjust this into kanang something useful sa imuhang calculation, what you need. So, if you need kilogram, then you use kilogram in equating that kanang percent weight. Okay? It's the same thing with percent volume. So, ang difference lang if I was told nga 30% by volume per volume, that means I might have 30 ml of the iron solution. I might have, not use iron, 30% of, 30 ml of butane, like C4H10. 30 ml of butane for every 100 ml of solution. That's the same. Okay? So, same ra na ang percent weight percent o volume percent except sa ilang unit. So, take note lang, class, nga dapat ang unit sa numerator is the same as the unit sa denominator. And sa numerator, it's the mass of, or the unit of the solute. Ang denominator is the unit of the solution total sa solute o sa solvent. Okay? Okay, next. Let's have PPM and PPB now. Okay. So, in the case of PPM and PPB, so for PPM, it's just like we are saying PPM, it's basically just 1 gram of a substance or the solute for every 1 million grams of the solution. That's PPM, or that's equal to 1 gram of solute for every 10 to the 6 grams of solution. Diba? Or, and in another case, ang PPB, that's 1 gram of solute for every 10 to the 10 to the 9 grams of solution. Kay PPB man, diba? 9 ka zeros ang billion. So, okay? And usually, class, ang PPM, we equate this with 1 milligram per liter. You know why? Because, ni siya, class? In the case of PPM, ha? So, it's equal to 1 milligram per liter because we assume nga ang 1 gram is equal to 1 ml or 1 ml is equal to 1 gram. Kanang we assume nga dilute aqueous solutions have the density of the water, have kanang density equal to that of water, almost equal at least. So that the density of water is approximately 1 gram per ml, di ba? So we assume nga ang dilute nga solutions, aqueous solutions, that has the same density. of water. So, if we assume that that's 1 gram is equal to 1 ml, that means 1 gram of solute for every 10 to the 6, diba, grams of solution. So, if we assume nga kini is kanang the same as the, diba, if 10 to the 6 grams of solution na, it's like saying 10 to the 6 ml of solution. Kay, gi-assume man nato nga ang 1 gram of solution is equal to 1 ml of the solution. Diba? So, if that's the case, so ato lang so that means 1 gram of solute is equal to 10 to the 6 ml of solution. Diba? Ato ra nang gitangtang ang gi-change ra ni nato ang grams to milligrams, which means 1 gram is equal to 1,000 milligram, diba? Cancel ang gram. And then gi-change ang ml to liters, that's 1 ml, 1,000 ml is equal to 1 liter. So, cancel. And then you solve that. Diba? So, it's 1 milligram per liter. In the same case, ang PPB pod, we can actually say it's like 1 microgram per liter. Okay? Now, let's have an example. Normal alkanes are hydrocarbons with the formula CnH2n plus 2. Plants selectively synthesize alkanes with an odd number of carbon atoms. So, the concentration of C29H60 in summer rainwater collected in Hanover, Germany is 34 ppb. And we are asked to find the molarity of the alkane, and let's neglect this part, and express the answer with a prefix. But we can try, but it's not a need, okay? Kay wala man ipakita sa table 1-3, okay? So, we know we are asked to find the molarity, diba? We know that that molarity is equal to the mole of solute per liter of solution. Okay? So, we need these two para ma-answer na to ang molarity. And we are given that the concentration of C29H60 is equal to 34 ppb. And we know that ang ppb, it means that this means nga there must be 34 grams in every 10 to the 9 nga kanang 10 to the 9 grams of solution. C29H60, di ba? Or, since ang 10 to the 9, that's equal to nanograms, di ba? Ang 10 to the 9, that's equal to a nano nga unit. Okay, so, you should know this, 10 to the 9, it's in nano. Na siya nga unit. Di ba? So, that means, we have 34 nanograms of C29H60 for every gram of solution. Diba? Okay. Now, we know nga, we assume nga ang, diba, in the PPB, we assume nga ang 1 gram of solution is equal to 1 ml of the solution. So that means we have 34 nanogram of, or no, let's just go back. Let's just use, because we're computing for molarity, so let's go to 34 grams of C29H60 from here for every 10 to the 9 ml of solution. Diba? So, we can just use the molar mass, which is 29 times 12 plus 3. 408.8. So, there's 408.8 grams of C29H60 for every 1 mole of C29H60. Okay? That means, that's how much? 34. Okay, missing pa day. Okay. ML pa manino, so we need to convert this to liter because we are asked for molarity. So 1,000 ml is equal to 1 liter, 'di ba? Okay, so that means we have 8.3 times 10 to the minus 8 molar. Okay? Now, para lang nga mawala ning times 10 to the minus 8, para we have a kanang value nga not in a scientific notation ba. Okay? So, para we have a more simple nga value, we use mao ni ang prefix nga giingon niya in table 1.3, which is micro, nano, okay? So, you have to know the conversion factors sa kanang milli, centi, deci, kanang mga prefixes, okay? So, 8.3 times 10 to the minus 8 moles per liter or molar. Okay, what would you use? Let's just use molar. Molar times, so for every 10 to the minus 9 nga molar, it's equal to 1 nanomolar, di ba? Basta raised to the power of 9, that's nano. Okay? That means we have 83 nanomolar. Okay? Okay, so now let's try to prepare a solution with a desired molarity. So like how much imong i-weigh, how much volume unsay gamiton nga flask, okay? Because this is the more practical application of concentrations. So copper sulfate pentahydrate or CuSO4 with 5 water molecules absorbed has 5 moles of water for each mole of copper sulfate in the solid crystal. Okay, that's basically the formula. The formula mass is equal to 249.69 grams per mole. Now, ang copper 2 sulfate without water, if copper sulfate lang without the water, has the formula copper sulfate and is said to be anhydrous. Diba? Of course, that's anhydrous. How many grams of copper sulfate pentahydrate should be dissolved in a volume of 500 ml to make 8 millimolar of copper 2 plus? Okay. So, we are given with the molarity of copper 2 plus. Okay. This is the molarity of copper 2 plus. And that's 8.00 millimolar of copper 2 plus, di ba? So, we need to make this. And the volume of the copper 2 plus nga atong buhaton, we need to make is 500.0 ml. Since kabaw naman to sa volume of the solution, that's moles solute, di ba? Per liter of solution. Since we know the molarity, we know this, we only need to calculate how much of the copper sulfate ang atong ibutang, di ba? So it depends on what you want to use. If copper sulfate pentahydrate or copper sulfate Ra. Diba? So let's say for example, we use copper sulfate pentahydrate. So it's just basic substitution class. So it's 8.00 millimolar, which is equal to, that's move 008 molar, di ba? Move 3 places, divide 1,000 man na siya para mahimong molar, di ba? Kay milli man ang unit. This is equal to mole solute per liter solution. And we know that we have 0.5 liter of solution. Di ba? So, that means, ang mole sa solute nga imong gikinahanglan, how much you need is 0.008 times 0.5. That's 4 times 10 to the minus 3 mole of solute of copper 2 plus. Diba? So, we only have copper 2 plus, diba? So, if we use copper sulfate pentahydrate, which is what's being asked, diba? We're being asked nga, atong gamiton is the copper sulfate pentahydrate, not the anhydrous one. Diba? So, what we need is ang molar mass nga atong gamiton is ang kining sa copper sulfate pentahydrate. Diba? Kay mao man ang atong timbangon. Maapil man og timbang ang 5 molecules of water. Inigtimbang nato sa copper sulfate pentahydrate. So, inig-compute nimo, ang apilon nimo, ang imong gamiton is ang copper sulfate pentahydrate para ma-include pod ang mass sa water inig-compute, diba? Okay, so we have 4 times 10 to the minus 3 mole of copper 2 plus times, that's copper 2 plus nga gikan sa copper sulfate pentahydrate, di ba? So that's 249.69 grams per mole, di ba? So that's 249.69 grams per mole per 1 mole of copper sulfate pentahydrate 0.5 H2O. Okay, that's the pentahydrate ha. Okay, so cancel na, di ba? Which means we have times 249.69. We have 0.999 grams of copper sulfate pentahydrate. Okay, so what you need to do now is to weigh 0.999 grams of copper sulfate pentahydrate. Remember nga, ang imong i-weigh is the pentahydrate because that's what you use in your calculation. Okay? And then, after weighing, you dissolve that in the flask, so in the beaker first. So, i-dissolve nimo gamay nga water first sa beaker and then imo iabo dire. So, this is the volumetric flask. This is a 50 ml volumetric flask. So, ang volumetric flask class, mao jud ni siya ang pang-measure accurately. So, this is very useful in analytical chem because this gives you an accurate volume. So, that's why we have 5.0 ml volumetric flask, 50.0 ml volumetric flask, okay? Because this gives you an accurate value nga volume. It's not like dili ni siya para sa Erlenmeyer flask or sa beaker, di ba? So, accurate ni siya og measurement. So, you dissolve 0.999 using you weigh 0.999 using an analytical balance. Okay? Remember, it should be an analytical balance, not just a top-loading balance. Okay? So, you use an analytical balance for this, and then you dissolve that a little bit so to distilled water, and then you transfer it here. Okay? So, remember to rinse the side of the beaker, and then when sure na jud ka nga nakuha na to nimong nasa kilid-kilid sa flask, you you fill this up to the brim. Kutob sa 50 ml nga mark. Kay naman na mark ang volumetric flask. Okay? And then, remember nga to read sa lower meniscus, di ba? Kay inig ka, ana ni mo, naaman na, ana man na ang now sa liquid, sa kinidiri nga part. So, ari ka sa lower meniscus, dapat mo read. So, dapat ang mark is naa ni level sa lower meniscus. Okay? And you should read it at eye level. Okay? Okay, now, let's try to prepare 0.1 molar of HCl. Okay? So, the molarity of concentrated HCl purchased for laboratory use is approximately 12.1 molar. How many milliliters of this reagent should be diluted to 1.00 liters to make 0.1 molar HCl? Okay, so this applies the formula for dilution. Okay, so dilution class is kanang very useful in analytical chem. So, when do you use dilution? Okay, so for example, kanang nag-experiment mo and then you need to use this reagent. For example, you need to use this 12.1 molar. Okay, this is 12.1 molar of HCl. You need to use this for several days. Okay, so like ikaugma gamiton, ikasunod ugma gamiton na pod. You can't it's not kanang practical to prepare every day, di ba? To prepare 12.1 molar every day. Kay aside sa usik siya sa time, mag different pa gid ang concentrations which might kanang pose another error sa imong experiment. Di ba? So what you need to do is to prepare a stock solution. Ang stock solution is mo na imuhang kanang mas dako nga solution, mas dako og concentration nga solution kay para if you want to prepare 12.1 man na imong stock solution. If you want to prepare 1 molar, imo na lang sagulan og tubig, i-compute na lang nimo, di ba? Para sagulan nimo og tubig to make a 1 molar solution. Okay? So, this is what we're doing in dilution. So, in the problem, that's 12.1 molar ang imuhang ang gi-purchase sa laboratory. Okay? That's the concentrated nga HCl. So we are asked how many ml of this HCl should be diluted to 1 liter to make 0.1 molar HCl. So what we need is to convert that into 1 liter, di ba? So this is 1 liter of 0.1 molar HCl. Di ba? Okay, so what you need to do is, of course, i-dilute yun mo. Diba? So, sagulan dyan na siya tubig. But, the question is, how much ang imong gamiton aning 12.1 molar? So, the formula for dilution is very simple. It's M initial times volume initial, or M1 V1 is equal to M2 V2. Remember nga, ang kining M1 V1 is sa imuhang first nga solution, ang M2 V2 is ang imong final nga solution, or MF VF. It depends on your kanang preference. So, M1 V1 equals M2 V2 ang ako ang technique, anak, kay para dali ra nako mahinumduman. So, you just substitute molarity of the final, or the final nimo nga imong himuon, that's 0.100 molar, times ang volume sa imong final nga himuon, that's 1 liter. Diba? And then, this is 12.1 molar ang akong stock solution. Diba? So, I need to find how much how much aning 12.1 molar akong buhaton. So, that's 0.1 times 1 liter, which means that's 0.100 molar liter over, divided by 12.1 molar V1. So, cancel ang molar. So, that gives you liter, which means that's 0.1 divided by 12.1, which is 8.26 times 10 to the minus 3 liters, or equal to 8 point, am I doing this right? That's the volume. Yeah, that's 8.26 ml. Okay. So that means ang imong buhaton ra, basically, you take 8.26 ml of this. So how do you measure 8.26 ml of that? You can use a burette nga 8 point, pipette ba kanang ay burette nga 8.26 or pipette nga 8 ml until nga moad siya 8 ml, or you can just use a micropipette directly, and then you can even use a graduated cylinder, and then you remember to acid to water. So you fill this up with a little bit of water first, and then you pour the acid before you pour the acid, okay? And then you fill this up to the brim until 1 liter. So this is a 1 liter nga flask. Okay? Okay, now let's try a more difficult more complicated problem. Okay, so a sample of an ore was analyzed for copper 2 plus as follows. So my technique for this class is I use flow diagram, kanang magbuhat jud ko og diagram to see the flow of the process, and also para makabalo ko which data are important, which data are useful sa calculation, because you will know that man. And again, this really takes practice para makabalo na jud ka which ones kanang sa first read pa lang nimo ba makabalo na ka which ones are important and useful in the calculation. Okay, so you have an ore, and then you need to analyze that for copper 2 plus. Okay? So, ang timbang sa ore is 1.25. 1.25 grams of ore. Okay? And this was dissolved in acid. So, gidissolve ra siya in acid, and then para mahimo ra siyang solution, and then gidilute to volume. Gidilute siya into 250 ml. So, it's using volumetric flask, which means that this must be important. This volume must be important, kay accurate man ang volumetric flask. And then, from sa 250 ml, nagkuha ra siya og 20 ml ana aliquot or portion. Aliquot, it just means portion of the resulting solution. So gikan sa 250 ml, nagkuha siya og 20 ml, and gitransfer niya into 50 ml nga volumetric flask. So gidilute na sad niya to 50 ml. That means 20 gipunan siguro niya 30 ml water until mo reach sa mark 50 ml mark sa volumetric flask. And after analysis, it showed nga this kini nga solution, the copper concentration of the final solution is 4.62 ppm. And now, we are asked for the weight percent of copper in the original ore. So, sa original ore, this is what we are asked, okay? Percent weight of copper. And we know that percent weight is the grams of copper or the mass of copper for every grams of solution or grams of ore. Kay ore man ang atong original. So, times 100. We know the mass of ore. That means we only need to find the mass of the copper nga present sa ore, given this. Okay, so, we of course, we start with what is given, which is 4.62 ppm. And by definition, we know that that's 4.62. It means we have 4.62 grams of copper present for every 4.62 grams of copper for every 10 to the 6 grams of solution. Sa kani nga solution, di ba? Kay mao man ni ang imong gi-analyze, mao man ni ang gi-check nimo ngadto sa machine, imong gisud sa machine. And ang machine told you nga it's 4.62 ppm. Okay? So as I've told you, nga ang kining ppm, we assume nga ang kining gram solution is equal to ml of solution. That means we have 4.62 grams of copper for every 10 to the 6 ml of solution. And we know nga kini nga solution is sa 50 ni siya nga ml, di ba? So if we remove the 50 ml, if we remove this ml, we know that we get the mass of copper. So we will get the mass of copper nga present ani. Ang copper nga present ana. 4.62 times 50 divided by 10 to the 6. So that means ang mass of copper is present sa 50 ml sa final nga solution is 2.31 times 10 to the minus 4 grams of copper. Di ba? And then, we know nga kini nga copper is gikan ni sa 20 ml. And kining 20 ml gikan ni sa 250 ml. Di ba? So, if we divide that with 20, di ba kini nga copper is mao ni ang mass sa copper nga nasa 50 ml. Di ba? And we know, nga kanang 50 ml, gikan rasad na sa 20 ml. So, the dilution factor would just be ang 250 ml nga initial jud niya ug ang 20 ml nga katong gibutang nimo sa 50 ml. Now, sayon ra kay niyang dilution factor class. Di ba magkasaka ka padung sa grams or padung diri sa 1.25 grams or dapat magka-concentrated jud, di ba? Magkadako jud ang mass sa copper kay gasige biya kag dilute padung ubos. So that means you should just multiply it with a bigger number. That means 250 over 20. Kay if imo nang i-multiply og 20 over 250, then that would become even smaller, di ba? But if you don't get that, you just have to analyze. So kato is technique lang to siya. But if you don't get the technique, then you have to analyze. So di ba? Ang kini nga copper 2.31 times 10 to the minus 4 is the mass of copper present in 50 ml. And you know nga ang kining 50 ml is ang sud ani is katong 20 ml nga gikan sa 250 ml. So pila man ka 20 ml ang imong ibutang, di ba? If imo ning isud ang 250 ml into 50 ml, di man pwede, di ba? So pila man ka 20 ang nasa 250. Di ba? So that's just 250 over 20. Pila ka 20 ang nasa 250. Di ba? So you cancel ml, you get the mass of copper in 250. In the 250 ml nga flask, which is 2.8875 times 10 to the minus 3 grams of copper. So that means at this point, we have 2.8875 times 10 to the minus 3 grams of copper. Diba? At this point, kining sa 250. Now, diba? Ang ore, ato ra nang gidritso ug dissolved sa 250 ml. That means, ang kini nga mass sa copper is already the mass nga present sa 1.25 grams nga ore. Kay mao ra man ni atong gidissolve directly into 250. So, now we can solve for the weight percent of copper, which is equal to 2.8875 times 10 to the minus 3 grams of copper all over 1.25 grams of ore times 100, which is equal to 0.231% weight of copper. And that's the answer.